In this video, we'll be looking at ways to balance chemical equations. When you balance an equation, the thing you're trying to do is get the same number of each type of atom on each side of the equation. In our first example, we can see that we have magnesium hydroxide reacting with hydrochloric acid to produce water and magnesium chloride. So what we're going to do is we're going to write out the types of each atom in the equation, and even though we have hydrogen in a couple different places here, we are only going to list it once because that's still the same type of atom. And then we're going to count up how many of each atom are on each side of the equation. In here, there's only one magnesium on the reactant side and one on the product side. In the reactants, there's one oxygen, but it's got this 2 outside the parentheses, so we distribute, and we would say we have 2 oxygens. And then on the product side, we only have 1. In the reactant side, we have 2 hydrogens plus another one in the HCl, so that's 3. In the products, we only have 2. And then the last thing we see here is the chlorines. We have 1 chlorine on the reactant side and 2 on the products. In general, we're going to save oxygen and hydrogen for the very last things to balance, oxygen for the very, very last. And so we're going to go ahead and balance this chlorine first. If we look, we have twice as many chlorines on the product side as the reactants, and so I'm going to add a 2 in front of the chlorine on the reactant side to double it. And that gives me 2 chlorines and 4 hydrogens. Now that I've got that, we need to go ahead and balance the hydrogens because we're saving the oxygens. So I can balance the hydrogens. If I look, I have 4 hydrogens on the reactant side and 2 on the products. So that means I need to multiply by products by 2. Giving me 4 hydrogens, but it also gives me 2 oxygens. And so if we look, everything's balanced. 1 magnesium, 2 oxygens, 4 hydrogens, and 2 chlorines on each side. And so this would be a balanced chemical equation. Let's go ahead and look at our second example. This is a combustion reaction, meaning all we have is carbon, hydrogen, and oxygen. And once again, in the reactant side, we have 3 carbons. In the products, we have 1, 8 hydrogens, and then 2 in the product side, and 2 oxygens, and 3 in the product side. This is where it gets really important to leave that oxygen for the very last thing, because if you look here, oxygen is only in one place in the reactant side, but it's in 2 different places on the product side, meaning that it's going to be very complicated to start there. The first thing we're going to do is we're going to balance carbons. So looking at this, there are 3 times as many carbons in the reactants as in the products, and so we're going to add a 3 in front of the CO2, giving us 3 carbons and making that balanced. But it does change our oxygens. Here we have 6, and then plus 1 more in the water, giving us 7. After the carbon, we need to save the oxygen, so we're going to do hydrogens next. There are 4 times as many hydrogens in the reactants as products, and so we'll add a 4 in front of the H2O, which gives us 8 hydrogens. And the oxygens, we have the 6 that are in CO2, plus 4 more that are in water, and so that's going to give us 10 oxygens, which means in order to balance this, we need to put a 5 in front of the O2, and then we're done.